Hi everyone, and welcome back. In this video, what we're going to do is we're going to convert the temperature data that we are reading in from our thermocouple. We're going to convert that into a floating point, and then we're going to see how to publish that data over MQTT on AWS IoT Core. So let's get started. First, let me get out of your way here, and let me bring back WinLadder. And if you remember from the last video, the last thing that we had done was we'd entered our connection control device and our connection status devices. We just need to click OK and OK. So we're back kind of in the main area in our main workspace. Now, let's take a quick look here in our module configuration where we've got a thermocouple configured. If you guys take a look, this is showing that it is a thermocouple data. Its valid data is from minus 328.0 to plus 2372.0. It's storing that in one data register, D8170, 16 bits. Now, you probably are looking at this and saying, hey, wait a second. There is a little bit of magic going on here, right? What's happening? Well, one, floating point data by default has to be stored in 32 bits. In our case, 2 consecutive data registers, right? Each data register is 16 bits. We're only using one. So what's going on? Well, what we're doing internally to allow us to only use one data register is when we read this temperature data, we are internally multiplying this by 10 to get rid of the decimal. So what we would actually see in the PLC is values from minus 3,280 to plus 23,720. It's an integer value, okay? It's a valid integer range. Integers can be stored in 16-bit locations and have values from minus 32,767 to plus 32,768. So values of minus 3,280 to plus 23,720 will fit just fine in an integer in 16 bits. So what we need to do in the code is we need to convert this from an integer into a float and then divide it by 10 to get our decimal back. Okay, so let's do that. So if I go into my main program here, I'm going to grab a normally open contact, basic, normally open, left click to drop it in, double click to edit it. I'm going to use a special internal relay, M8125. This is called the in operation output. What this means is whenever the PLC is in run mode, your program is being executed, this normally open contact will be on. So everything out to the right of here will happen on every scan of the PLC. That's what I want. All right, so let's go and convert that data from an integer to a float. To do that, we go to the advanced section in the instruction portion of the ribbon, go down to data conversion, and then about 3/4 of the way down, we've got convert data type, CVDT. That's what we want. We click on that, we'll left click to drop it in, and double click to edit. Here on the left side, we've only got one option selected for the type, CVDT. That's what we're doing. Down here in the bottom left, we're converting from an integer into a float. Source 1 is, what are we converting? Well, that's the value in D8170. That's where our thermocouple is wired to. Destination 1 is, where do we want to store the floating point data? And let's just use data register D100 as the starting address. Now remember, this is a raw float temperature, and it uses 2 registers. So it's in D100 and D101. 32 bits consecutively as a floating point. Okay? All right, good enough. Now let's go in and divide this value in D100 by 10 to get the actual temperature. So we'll go in here and draw a ladder line down, and let's put in a division instruction. So if I go to advanced and binary arithmetic and division, left click to drop that in, double click to edit. Again, here on the top left, my type, I'm doing a division. That's fine. Bottom left, my data type. Now at this point, it's a float. It's 32 bits. My source, my S1, is data register D100. And it's going to look at this as a float, 32 bits. My source 2 is what do I want to divide that by, and I want to divide that by 10. And D1 is destination 1. Where do I want to store this? Well, maybe I'll store this in D102. And this is my actual temperature and float. Okay. And again, this is using 32 bits. So it's going to use D102 and D103 consecutively. Okay. All right, good enough. Let's go ahead and download that to the PLC just to make sure that we're getting reasonable values in here. So if I go to online and download, and okay. Now let me go into monitor mode and see what I've got. Okay, so here in D8170, you can see it's bouncing back and forth a little bit, but it's around 810, 814. So it's about 81 degrees in the little control box where the PLC is mounted with that thermocouple. Okay, we're coming down here, we're dividing it by 10. So the actual temperature in that control box is about 81 degrees. That's reasonable. I'm okay with that. All right, let me go out of monitor mode. Now what we want to do is go in and configure the PLC so that we can actually publish that data. So if we go back into our MQTT configuration, if I go to configuration, Ethernet port 1, and I scroll down to the bottom, click on the configure button there for MQTT settings. And now I need to go into this publish menu here on the left-hand side. Click on publish. The way MQTT data is sent, it's within messages that are part of topics. So we can specify a topic name here. This can be just about any name you want. I'll call it FC6A/data, for example. Our payload is the message that we want to send over this topic. So if I click configure, I can set up my payload. Now, what is it that I want to send? I want to send the value of my temperature. So I'll come down here and click on new value. For the name, well, since it's temperature, I'll call it temperature with a capital T. My data type is a float. Remember, we just did the conversion for that. And that data is stored as a 32-bit number in D102. And you don't need to do that leading 0. I did that by mistake. It doesn't matter. The software will fix it no matter what. But you can just type D102 in there. I had typed it as D0102, which you don't need to do. Okay. So D102, put it back. Okay. And again, this is using D102 and D103. It's grabbing the value out of those 32 bits. Okay. And it's going to publish that over MQTT. Okay. That's all I need to set up there. Now, for my operation mode, I've got a couple of choices. You've got rising edge and you've got fixed period. Fixed period will send the data out every so often as long as your publish control, whatever bit will you put here, is on. Rising edge will do it whenever your publish control bit turns on. Okay? So for example, if I wanted to put a publish control bit here of, let's say, M200, internal relay M200, and I had this set to rising edge, whenever M200 turns on, just the action of going from off to on, when that happens, this message will get published on this topic. Okay? If I have it set to fixed period, again, I can specify a time, whatever I want in here, 5 seconds, 10 seconds, 8 seconds, 12 seconds. You can configure this interval. But in that case, if I had M200 here as a publish control bit, as a fixed period, once M200 is on, every, in this case, 10 seconds, this topic and this message will be published. Okay? So rising edge looks for the publish control bit to turn on to send the message. Fixed period is once this publish control bit is on, it will send it periodically based on the time setting that you have here. Okay? In my case, I'm going to do this just on the rising edge and then set up a little bit of logic. But you can do it either way. So I'll do rising edge. For the publish control bit, I'll use internal relay M200. And for my publish status, I'll use a starting address of data register D200. Okay. Now you'll notice once I hit the tab key, it shows our occupied device addresses as M200 for my publish control bit and D200 to D203 for my publish status registers. So this publish status actually uses 4 consecutive registers. Just something to keep in mind when you're setting this up. And once we actually go in and publish data, we'll look at these registers and talk about what each one of these is showing us. Okay, for QoS, what that stands for is quality of service. You've got 3 choices, 0, 1, and 2. And what these have to do with is just how often the message will try to be sent. Okay, so typically most brokers will support 0 and 1. Some of them will support 2. The higher the number of QoS, the higher the bandwidth, the more bandwidth that you're actually using for that particular message to be published. So in this case, I'll leave it at QoS of 0. The retain checkbox, this is usually dependent upon the broker, whether the broker does support retaining the messages or not. In the case of AWS, I'm just going to leave it off. And then again, our occupied device addresses here are M200 and D200 to D203. Okay, good enough. Let's go ahead and click OK. And click OK. And now in the next video, what we'll cover is we'll actually go through setting up that control connection bit, turning it on, and actually seeing it get published into AWS IoT Core. So hope to see you on the next video.